Hi guys, how are you doing? I'm Suleiman and I'll be showing you guys what I've learned so far in computer vision using OpenCV. So I I think I started just yesterday. I just had this motivation to try and take a look at how computers see. So naturally I went with OpenCV because it's the most popular out there, and I I didn't like going with Python, populated frameworks, because there are lots of tutorials and I don't know why I just shy away from Python. So anyway, yesterday I was like, what, I have to just do it. I have to just go to it. So as expected, I went to the OpenCV website, the official website, and I think there were courses there. So I took one of them that kind of like introduces you to the API of OpenCV, and I started learning. It was a video course, and currently I'm in. I think I should be in yeah, image filtering, edge detection. So even though most of the courses are in Python, I found a wrapper around the OpenCV C++ library, because actually it's in C, and Python kind of like runs the C code using interrupts. So in C Sharp we also have interrupts. So there's a wrapper that wraps the C library, so you can just use your normal C Sharp, normal C Sharp APIs to call on C code. I think it's called pinvoke. So yeah, so I followed along with the course, and fortunately most of the APIs like basically the same. Even though Python is more concise, you can write fewer lines of code with Python, but C Sharp is an option. So I'll go with that. So I now started a project, and let me show you guys what I did. So what this code just does is it takes a video frame. You know how pictures are actually grids, right? Like it's just a table with different pictures, and then those pictures can be multidimensional. For example, you can have a black and white or grayscale picture. So all it stores is a value from maybe 0 to 25. It doesn't have to be 0 to 25, but it stores a value, a range of value, and those values determine the color from black to white. So that's kind of like one dimensional uh, this thing, table. And you can have multiple dimensions, like or called channels in image processing language, and that's like a table with multi-dimensional values. So it's like in 3D, it's like 3D, right? So you have maybe one of the tables for red colors, like the red values of the pixels, one for the blue, one for the green, and some have one for alpha transparency, the transparency uh, pixel value, and all that. So video frames, it's also like the same, right? You have like pixels, but it has another extra dimension for time. So like what time are we currently in, and then how many frames to expect per second and all that. So I loaded the video in OpenCV using the create frame resource video, but I think it is capture video. Yeah, I think video capture in Python, but yeah, this is just like C# does the same thing. And then created a window, and then we are in our render loop now. So all this code does is to get the current frame, or the next frame actually, and then I have three modes. There's the preview Canny. Canny is a filtering method. What it does is take all the pixels and then kind of like filters it, and like you just process those pixels. Maybe you want to do something. Basically, it changes the values of the frame depending on the algorithm. It's a filter. You can use it. You can do anything you want. So blur is also a kind of filter that kind of like what it does is uh, it makes the differences between nearby pixels, like kind of like, how will I say, it smoothens the pixels, so it doesn't look as sharp as it is. So it's also a filtering method, and what I just do here is to validate the values. so that you don't have like negative values for the algorithm. Some don't support it, some don't, like 0 and all that. So this is just some validation before I call the actual algorithm to manipulate those pixels, and then I put it in this other matrix, and 0, it's just a matrix table. And at the end, I put in some text and then display the like resulting matrix, but in my window I just call it W0. And this simply sets a loop. So when we are at the end of the frame, when there's no more matrix to be shown, I just reset it. So go back to the first frame. That's what this reset does. And this is for the input. Maybe after I render the frame, I kind of like wait for a short delay of 2 milliseconds, and I think it should be milliseconds. And if you tap on the key at that frame, then I'll just like go ahead and like do something about it. So I have some key bindings for setting this current render mode to like canny, filter this and filtering algorithm, to blur, and then to preview. Preview doesn't do anything, it just takes that same matrix and then it doesn't filter anything. And I have a few variables for modifying the algorithms themselves. So let's go back to canny, and you see that I pass in an X value and a Y value. These are the threshold of the algorithm, and the threshold is just okay for each pixel value, like what is the threshold for me to kind of like manipulate. Like it's just it's threshold for managing like nearby pixels for the algorithm, because what it does is like sees like the sharpness like of like the different values between each other, like maybe to take a block size. I think is there a place for block? Can see. So I'm not sure exactly how the algorithm works, but what it does is like it has a threshold for the pixel values, and then if it's less than a threshold, then it will like ignore this one. It's okay, this is definitely not an edge. Okay, sorry, this kind is for edge detection, I forgot to mention. So this is not an edge, and then if it is above the threshold, then it will like consider that okay, this might be an edge and all that. And so I assign the value to it so that I can be able to modify it in real time and see how it changes, you know, how the different values affect the video. And then the blur also, it has a blur size, and basically this blur size is just the block, you know, like it's just you just give it a rectangle, and then it will like check that rectangle and then kind of place it in all the videos. So the smaller the blur size, the more it doesn't really blur that much, and then the bigger it get bigger. Yeah, so it doesn't like that's like a smoothing in space. And yeah, so the WASD for manipulating those values. And yeah, so let me show you guys what we got so far. Sorry. Yeah, so currently it's in the preview mode. So you see it doesn't change, there's no filtering at all. And then if I switch it to blur, you don't see much, but if you look at the top left corner, you see the values of X and Y. It is 1 1 because the block space is like 1. If I increase it, the X value, I hope it's visible. Is it visible? Yeah, so if I increase the value, you can see the blurriness is increasing, but it's in just one dimension, the X-axis. So imagine like it's blurring things that are like this in lines. And if I increase the Y, it's becoming more choppy, like it's like a box. And if I change the mode to preview P, I think I should make another text that displays the current state. We go back to normal, and then we have the canny. So this is the interesting one. This kind of like check the different pixels and then check the difference between the neighbors, and then determine whether this qualifies as an edge or not. So currently the X value, the threshold, if you remember, the threshold is 10 and then 20. So what happens if we decrease the threshold? You can see like a lot more pixels are being considered as edges, and that's pretty much not what we want. Let's look at the original video. Okay, I think we've seen it. Yeah, original video. So there isn't like it shows like this edges where they are not, because the edges should only be on the object, the rest is in the background. So let's increase the threshold so that not every little bit of corner or difference is considered as an edge. So let's increase the X and Y, and if you see, the more we increase it, the more accurate the edge detection algorithm works. You can, so you get closer to something that looks pretty much like pretty reasonable. Yeah. So anywhere you see black, it's just 0, right? It's just a value of 0, and then anywhere you see white, it's a value of 1. So what the Kani does is, like, anywhere we detect an edge, we're going to give it a value of 1. Sorry, not 1. The highest byte, 255. So just give it that value, and basically it's like, okay, there's a color, there's no color. So it's called a binary map. So yeah, and then you can use this and mask other objects. Like now I can kind of, like, let's say I'm looking for this object in particular, I can use the edge detection to, like, determine where the object is, and then look at the matrix and see where the last one value is on the left, and then kind of like crop it, because the cropping is just taking a subset of the table. Like, that's pretty much what it is. And also, if you notice, it looks slower than the preview, and the reason is this one, like the filter, you have to, like, apply lots of do some calculations per pixel, on a very, very large image. I think the video is around, hold on, let me check, it's 1600 by 1200, the resolution. So if you multiply those, like 1600, 1200, it will give you the number of pixels, individual pixels, and that's like a very big number. I'm talking about millions. So that's why it's taking time. So that's why you see many algorithms, they're like and AI models too, not AI, but like machine learning models for image detection, object detection. They use a smaller resolution because it's more performant. Even if you have, like, a very big video, to kind of, like, first resize the video to something more efficient, like maybe 1080p, depending on the machine. Most that I've seen so far is like 720, so that the calculations will be plenty, and then apply those algorithms, and then that there's lots of filtering that goes on in the image processing pipeline. So yeah, thanks for listening.